Okay, today we're taking a look at Lesson 10 for Module 2 for 5th grade. And this is, once again, using that area model, but it's kind of in a different way. This time around, we are looking at multiplication of decimals. And it's asking us first to estimate the product, and then solve using an area model, and then the standard algorithm. So what you have for your homework this time is really similar to this. I'm going to ask you to pick one of these, and it's telling you to do the exact same thing I'm about to demo. So estimate the product, solve with the area model, and then the standard algorithm. That's what you're going to be doing for your homework, is picking one of those two problems. So watch closely. Here we go. The first thing we're going to be doing, it says, is estimating the product. I think that 53 is really close to just being 50. And 1.2, $1.20, say for example, really close to just being simply $1. And so that's going to get us a total of 50. And now when we go to put this into an area model, we're going to go ahead and kind of change up, and this is going to be right here, 12 tenths. 12 tenths. So then that way we kind of have gotten rid of the decimal, right? We could think of it as, if it's 10 tenths, you have a whole, and so in this case we have 12 tenths total. And then we're going to take our 53, and it's going to go here. So it's going to divide things up a little bit. When we go through and we say 3 times 10, it's 30, and we go 3 times 2 is 6. So we can say then, this is going to become 36 tenths. And for every 10 tenths, we actually have a whole. So this means it's probably going to be 3 whole, right? Now let's take a look at this over here, and we know 5 times 1 is going to be a 50, right? But we've already got a 50, so we think about our place values. So we know that's going to be a 5. We know 2 times 5 is also a 10, so that's going to carry 1 over. So if you have 5 times 1, you get your 5. And then if you're carrying 1 over, that's going to actually give you a 6, isn't it? And then we've got, say, if we were kind of working it out, we're going to have a couple place values, right? Because I know that 10 times 50 is actually 500. So in this case, it's not going to be smaller than 500. It's going to actually become 600. And this, we're going to use that same noun. So my computer's thinking briefly. That's what's up with that lovely little rainbow spinner there. So I'm going to be writing tenths. Tenths. If we can get this to function. T-E-N-T-H-S. Tenths. So that's our noun, tenths. This is our adjective, how many do we have? And so when we go through and we do it this direction, and it's saying right here that it's tenths, so we'll worry about that at the end. 3 times 2, as you know, a 6. 3 times 1 is 3. So these partial products match. And then we're going to look at this, see how we get it. We know that 50 times 2, we're going to have a 0 in the ones place. And so then 5 times 2, that's that 10 we were talking about, that we carry. 5 times 1 is 5, plus 1 more gets us that 6. Now when we add them together, we're going to bring down the 6 because we're adding nothing to it. We bring down the 3 because we're adding nothing to it. The 6 just comes on down. And we know that 600 plus 36 gets us 636. And if it's tenths, so do you remember we used that place value chart? Remember those days? And so on our place value chart, we had a place where we had a decimal. And then over here next to that decimal, this was the tenths. Looks like a 6, doesn't it? This was the tenths place. And so when you had the tenths place there, if we put 636 here, 636, you remember this is going to move two place values over here. This is going to move over here, and the 6 will stay. So 6, 3 point, let's see if we can get it to actually make our decimal, 6. Because for every 10 tenths, you actually have a whole. So your parents were taught that when you do this, all you think about is 1.2, and that you don't worry about the decimal till the end. You get to the end, you've done your multiplication, and you go, oh, there's one decimal place up here, so let's put one decimal place in here. So it's like thinking about if you move it like that. That's how we as parents were taught. But as far as if you had ever asked us why, I don't know if we really could have told you. So that's what this next thing is going to be exploring, is this right here. And this is kind of moving toward the standard algorithm idea. And so if we have here, we're going to start with our estimation. This is going to be 3, because it's 3.3. 16 is really closer to 20, right? Because that midpoint, the 5, we've passed it. 3 times 2, 6. We bring over 1, 0. When we go to do this with a standard algorithm, this is kind of what your parents were not taught, or me for that matter, times 16. And what we can do, when they say get rid of the decimal, what they're saying is multiply it times 10. And do you remember when we multiplied something by 10? It meant that it gained a place value. So the idea of if you multiply it by 10, it becomes 33 times 16. And now when we do this, we go 6 times 3 is 18. 6 times 3 is still 18, plus 1, add a 9 into there instead of an 8. And now we go 10 times that, so we have to have a 0, because 10 times anything ends in 0. 1 times 3 is 3, and again, 1 times 3 is still 3. And now we go through and we add them together the same as we always do, because multiplication is repeated addition. 8 plus 0 is still 8, 9, 10, 11, 12. We carry our 1, 3, 4, 5. Now, what we did up here was multiply by 10. But in order to get our real answer, we have to do the opposite of that, so that we can go back to what we originally were supposed to have. And that, the opposite of multiply, is divide, right? By 10. So the opposite, to make this go away, because we changed our number, to make it easier to work with. But to make our answer accurate, we have to make that go away. We have to do the opposite. And you remember, we gained a place value this way. Now we're going to lose a place value to get back to where we started. And so if we lose a place value, we know our decimal will be here. Because now 528, if the 500 loses a place value, it goes from the hundreds place to the tens place. And that's what your parents learned without being told how come. We were just told that you ignore the decimal, and then you count how many decimal places there were in your problem, put that many decimal places in there. But we were never really taught how come. Now you know why. So I'm going to cruise on up to those problems because we're almost at that 10-minute mark. So right up here, I'm going to ask you to pick one. And I want you to do it the same way that I just showed you. So these, you're going to start with your estimation. Think 33. Look at the number right here. It's only a 3. That's just going to become a 30. 21, look at that number right there, the 1, isn't going to impact the 2 because it's less than 5, so that's going to become a 20. If we do these, 7 is higher than 5, that's going to become a 2, right? 55, because that's a 5, that's past the midpoint, that's going to become 60. And when you multiply these, you get your estimate, so you can have a good idea of how it's going. And now when you actually go through, you're going to do, let's say, an area model. So this one right here is going to be 332 tenths. This one is going to be 17 tenths. Here's what that looked like, where we had our whole number, and then we had, what is the noun? It's tenths. And then you remember, look at this over here, look at this place value chart, that if you had more than 10 tenths, they change place value. Okay? We're going to do some like that one that I showed you with your parents. This one right here. We're going to do that in class. For tonight's homework, pick one of these. Ready? Go for it.